Unit 4, Day 1. In Unit 4, we're going to prove triangles congruent. On Day 1's lesson, we're going to first classify triangles by angles and sides. First, we're going to classify triangles by their angles. The first classification is acute. An acute triangle is a triangle that all angles are acute. In other words, less than 90 degrees. Then you also could have a right triangle. On a right triangle, one angle is a right angle, exactly 90 degrees. There are obtuse triangles. An obtuse triangle has one obtuse angle, which is more than 90 degrees. And lastly, you have an equiangular triangle, where you have three congruent acute angles in the triangle. So those are the four classifications based on angles. Now we're going to classify the triangles based on their sides. The first classification is scalene. Scalene is when a triangle has sides of different lengths. Isosceles is a triangle where at least two of the sides have the same length. And then you have an equilateral triangle where all the sides have the same length. So these are the three possible classifications based on their sides. In this first example, they want us to classify each triangle based on their angles. So tell whether it's acute, equiangular, obtuse, or right. And then explain our reasoning. All right, first we're going to look at triangle ABD. It's right here. When I look at triangle ABD, all three angles are acute and they're congruent. So the classification would have to be equiangular. Now we're going to look at triangle BDC. BDC is this one here. And when I look at triangle BDC, I notice that there is one obtuse angle. That obtuse angle is 120 degrees. So that means BDC is an obtuse triangle. And last but not least, we have triangle ABC, which is the big one combining both of those smaller ones. And when I look at this angle, we have 60 degrees here, 30 degrees there, and then in this bottom corner here, we have 60 and 30 together, which would make 90. So that means triangle ABC is a right triangle. So right. Please do example 2 at the bottom and make sure you take a picture. On example 3, we're going to find x and then the lengths of all the lengths of this triangle. If you notice that two of the sides have a tick mark. When you see a tick mark on a leg or a side, and it is the same style of tick mark, it means that that side and another side have the same length. So what I'm trying to tell you is that JK will have the same length as LK. So it looks like it's going to be an isosceles triangle. So now that I know that JK will have the same length as LK, I can set up an equation. So I would have 4x minus 1.3 equals x plus 2.2. Now I can solve for x. First, I would subtract x on both sides, which would give me 3x minus 1.3 equals 3.2. Then I would add 1.3 to both sides. So 3x is equal to 4.5. And then divide both sides by 3. So x is equal to 1.5. And now that I know what x is, I can use it to answer the rest of the questions. First, I'm going to find the length of JK. JK is 4 times x minus 1.3. So that means 4 times 1.5 minus 1.3. Let's grab our handy dandy calculator. 4 4 times 1.5 is 6. Then I'm going to subtract 1.3. And that'll be 4.7. So JK is equal to 4.7. LK is supposed to be the same length as JK, but let's be sure. So LK is equal to x plus 3.2. X is 1.5 plus 3.2. So that would be 4.7 again, which is true. So now the last one we have to find is JL. JL is equal to 5x minus 0.2. So that's 5 times 1.5 minus 0.2. Let's grab our handy dandy calculator. So 5 times 1.5 is 7.5. And now I'm going to subtract 0.2. And that would be 7.3. So now I have x and all my side lengths, as I was instructed to do so. Please complete this final example and snap a picture. And this concludes your notes for today.